All right. So one quick announcement, right? So um, for this web work homework, right, you need to score at least 70% to pass the course, right? So this is a mandatory requirement. I learned yesterday, but I just want to let you guys know. So you have to do the homework, right? If you score 70% or better, you, you are eligible to pass the course. Obviously, also the final exam, right? You're gonna pass, get 70% on the homework, and then I also pass the final exam. Yep. So we're gonna talk about chapter 2 today. Right. So let's get started. Let's get to the note. Okay. So we're gonna take a look at on chapter 3. It's about linear equations and also the inequalities. Right? So let's take a look at it. So chapter 2. We'll talk about linear equations. Inequalities. All right, so first of all, let's start with the like terms, right? So like terms. So if two or more terms. With the same variable part. It's called like terms. Same variable part. That's called a like term. So for example, 2x and 9x, they are like terms, right? So that's the first one, like terms. Because they have the same variable, and a variable has the same power, right? The exponents are the same. So that's called like terms. But if you look at next one, let's say 2xy, and then 9xy squared. Now these two are not like terms because they have the same variable, but the power for the variable y is different. So this is not like terms. We can say unlike terms. So this is very you got to be very careful about this when you combine like terms. You know, so for example, if you're adding 2x and 9x, right, you keep the x, you add in a coefficient. Or another way of looking at this will be factor out the x and put 2 and 9 together. So 2 plus 9 equals 11, right? So that's why this is 11x. And when they are unlike terms like 2xy plus 9xy squared, then we'll leave it like that. There's not much we can do. We just keep as is. And next thing I'm going to show you how to simplify like terms. For example, let's say we want to do 7a minus 10a adding 3a, right? So again, when we combine like terms, first of all, they're like terms. They all have the variable a, and variable a has the same power. So you can factor out a. Now you get a 7 minus 10 plus 3 inside the parentheses. And then 7 minus 10 is negative 3. Adding 3, and that is 0, right? So 0, 8. 0 times 8, that's 0. And then also something like this, we get 3x plus 5, adding 2x minus 3. And when you combine them, you combine the variable term first, so you can switch them if you want to. So 3x plus 2x go together, 5 minus 3. So 3x plus 2x, that's 5x. 5 minus 3, that's 2. So answer is 5x plus 2. And yeah, so basically you can switch the neighbors, right? You can switch them if that brings convenience to the calculation. Any questions so far? All right. So let's say we get something like 4a minus 7 minus 2a adding 3. But again, we just switch the order of those three terms, right? So 4a minus 2a, using the commutative properties, switch the minus 7 plus 3. So you combine like terms, 4a minus 2a, they are like terms. 4 minus 2, that's 2, carry over the a. And minus 7 plus 3 is like 3 minus 7, so we be minus 3. Right. Now I want to go back to the workbook. I want you guys to try some of the questions from the workbook. So here, so starting this class, right, I'm going to use a lot of examples from the workbook. So, you know, you learn, so you understand what a homework question look like. So you can also solve the homework problem, you know, fairly quickly. Let's see. Right, let's take a look at this. Write this expression in this simpler form, if possible. So you're gonna put all the variable terms together, right? Put the numbers together, like in two different groups, and then simplify each group. Okay, guys, let's go over the solutions here, right? So first of all, we're gonna put this 2x, 3x, and then ax together. So it becomes 2x minus 3x and ax. Yes, Gavin, you have a question?
Yeah, so this is my first time in this class today. So what time does this class officially start and officially end?
8:30 to 12:30, Kevin. And also, you know, if you missed yesterday's class, you should contact the office, right? Because there's no absence allowed. So you should email them as soon as possible. you know, and settle the issue with them. Just explain why you were not here yesterday, and let's see what they say. Because they do not allow any absence. Even the ladies, right? Even late for 2 times, they're gonna send you warnings. So they're very strict in terms of attendance. And they want you guys to do well in the class.
What's the email? I could email.
Okay. Yeah, email the office. Okay, very good. And then the remaining numbers, right? You're gonna put it together, 6, 5, and right. You're gonna put in another parentheses. Plus 5 minus 8. Now we start combine like terms. So 2 minus 3 is negative 1x plus 8x. Right? On the right hand, on the other side, it's 11 minus 8. Now here we get a 8x minus 1x. You can look at it that way. That's going to be 7x. 11 minus 8 is 3. So the answer here will be 7x plus 3. Okay. Any question about this? Okay, so let's go back and put in the answers here. 7x plus 3. Okay. So here on the side, right, just in case you miss some, let's say fractions, absolute values, square root, any root, we're going to learn this later, right, in chapter 8. Exponent, infinity, pi, all this, you can get it here. And you can submit it if you get instant feedback, right, whether it's correct or incorrect. So let's look at the next question, right? Let's see. All right, let's try this. You're going to simplify the following expression if possible. Yes, Sarah, question?
When you say simplify the following expression, do you mean like you want another expression or one answer? Like one.
Just single answer. For example, let's say you do 3r minus 2r, right? So you subtract 3 by 2, you get 1r. And then you just leave it as r. That's what we mean. So basically, it's simplify as much as possible. And usually we turn into single terms if possible.
Okay.
Yeah. Okay. Give it a shot.
Okay.
Mhm. Yes, Maya, you have a question?
We can't combine like unlike terms, right? So like if
Yeah.
there's an exponent, it can't go. So you just leave it as it is.
Yes, exactly. Like question 3, right? You see,
Yeah.
exactly right. You have a good point. So same variable, but the power are not the same. So you're just gonna leave it as is. 3r to the 4. There's
Yeah.
nothing you can do. Yes, that's right.
And then for the second one, do we multiply those two
Yeah,
together?
you multiply. Exactly.
Okay. Thank you.
Try that, right? Give it a shot. All right, let's go over solution. So for the second one, you multiply two variable terms. So multiply number first, 3 times 3 gives 9. And r to the first, and r to the first, you do 1 plus 1, right? So the exponent operation is like this, and if you get a to the x minus a to the y. So you're going to keep the base a when they have the same base and add exponent. And here by default, there should be 1 on top of r. So you combine them then minus 3. And very similar for the fourth one, right? We multiply 3 and 3 first, we can 9. And then for the r, find this property, right? This is a multiplication property. Also the quotient. So I'm gonna just write out all the properties. A over a to the x over a to the y equals a times 1. And we get a to the x raised to the y power. We get a x1. Multiply the inner power by the power outside. So that's a to the x1. Right here we adding 1 and 4 using the first property. Adding 1 and 4 we get 9 to the fifth power. Any question about this? So we get 1. Yes, Maya, go ahead.
I thought you can't,
Mhm.
because aren't those unlike terms?
Yes.
Number
Yeah, it's only when you adding or subtracting then you care
Oh,
about whether or not they are like terms. But when you multiply, then you just follow the other rule, right? Which is the multiplication rule. Like this, you follow the multiplication rule or division rule. If it's not only adding, subtracting.
okay. So only adding and subtracting, you have to worry about the like and unlike terms.
Exactly.
And then multiplication and is it also for division as well? Where
Yes.
you don't
So,
worry about the unlike terms?
right. When you multiply, you follow this rule, right?
Okay.
When you divide, you follow this rule. And when it's the exponent raised to another exponent, then you follow this rule. Okay. So
Okay, can you just keep that up for a second so I can write that down?
yeah, sure. We can note that down. Sure.
Okay, I'm good. Thank you.
Okay, sure. Yeah, let's go back and we're gonna just put in the answers in the answer box. The third one, there's not much we can do. We just carry over the entire expression. So 3 times r to the, put in the multiplication sign, no problem, to the fourth power. And the last one will be 9 times r to the fifth power. Okay. So that should be the correct answer. Then let's just submit it. Check the answer. Yeah, they're all correct. It's all good. So now let's look at the next one. Yep, we try this one, right? Really quickly. So you're gonna put an invisible one back, right? And distribute it. Then combine the numbers after this. All right, so while you're doing this, I'm gonna call in attendance, right? Marion,
Here.
okay, great. Gavin is here. And Alexandra,
I'm here.
okay. And Bianca,
Here.
great. Inta, no, she's not here. And Mirza, and Ashley,
I'm here.
okay, great. And Nathaniel,
Here.
okay, right. And Benjamin, Kareem,
Wait, did you say
I'm
Benjamin?
here.
yes, I say Benjamin, I'm Aki, yes. And
I'm
Kareem,
here, Professor.
okay, great. Thanks. And Nahi,
Here.
Ivania,
You said Daniel.
Yes, Daniel Amaku, yeah. Okay. And Ivania. No.
Wait, what
Did
you
you
said?
did you say my name?
What is your name?
Gavin.
Gavin Amaku, yes.
Oh.
I met you earlier. Yes, I called your name. That's right.
You marked Nathaniel, right?
Uh, I haven't called you yet, Daniel. Yes. Maya is here.
Nathaniel?
Huh?
Yeah, I'm here.
Okay. Mike? Mike. No, Mike is not here. And Sarah is here, right?
Sarah's here.
Okay. Great. Um, Daniel.
Here.
Okay. Oh, Daniel, also, you missed yesterday's class, right? So you should email the office and explain to them, you know, what happened yesterday. Yeah, so, okay.
I bet.
Yeah, sure. Okay. Jonathan,
Yeah.
Anta, no, okay, today. And then, Kalena, right. All right, so let's go back to that question, let's complete it. Okay, so you should go back here and just basically put invisible on that and distribute it. We can get 7 minus 3, minus 3, right? -1 times 3 is -3. -1 times 10a, minus plus is minus. I know. From there, you're just gonna combine those two numbers. 7 minus 3 is 4. So that's basically the correct answer, right? 4 minus 10a.
I have a question.
Yeah, sure. Go ahead.
How did the addition turn into subtraction?
How do addition turn into subtraction? So, okay, so going back here. Okay, remember that's the invisible one. So, you get 7, right? Minus 3 plus 10 is. First of all, this we should put back this invisible one, right? And then distribute it. That's how we look at it. So it will be 7. So carry over the 7, then you get -1 times 3. So -1 times +3, that's minus, right? And then 1 times 3 is 3. Like it's a sign operation. You put back the positive sign here. Minus times plus is minus. Get the sign first and then multiply 1 and 3, you get 3. And similarly for the second term, -1 times 10a minus plus is minus. 1 times 10a is 10a. Does that make sense?
Is that invisible one always there? Like if there's a negative there?
Yes, it always there. That's right. You can go by the same rule here. That will make it slightly easier to understand. And also another way of looking at this is if we look at this negative sign in front of it, you can just this negative sign when you turn everything inside to the opposite. That's also a good way to look at it. So 3 becomes a 3, 10a becomes plus 10a becomes minus 8. So anytime you have a negative sign in front of the parentheses, right? You're going to turn every single term inside of parentheses to the opposite term. Yeah. And after that, you can just combine numbers, same on the 3, 4, and carry over. Yeah, and not like terms, you're going to leave as is. Okay, it's very good. This is a very good question, and then a lot of students have issue with this, right? But I hopefully you guys don't have issue with this. All right, so 4 minus 10a, that's correct answer. All right, next problem. Okay. Use distributive property to simplify this completely. So you're gonna distribute this, right?
Excuse me.
Yes.
I'm doing one of the assignments,
Yep.
and I put an answer, and it says it's incorrect, but the right answer is the answer I put.
The thing is that Gavin, the webwork system is very accurate. It's coded by a math professor all over the country. So you shouldn't have any issue with the inputs because I've been using system for more than 10 years. I've never seen anything
All
like
right, so
that. So
I'm doing the first problem set, addition of real numbers, problem 10. The answer was 130. I entered 130, and it says it's incorrect.
okay, so again, I'm gonna go to your account really quickly.
I had an issue with problem 10 too, Professor, with the homework.
Okay, sure. Okay.
Yeah.
1.3, right? Real numbers. Question 6.
The first homework, yeah.
Yeah,
First
okay.
set.
Question 10, right?
Yeah.
Okay, let me take a look at it. All right. So January 1st, you had a balance of negative $390 in your bank account. Your bank charged $30 overdraft fee. Okay? That means when they do that, what does that mean? Is it
It's going into a negative.
exactly so minus 30, right? So you can do that.
Yeah.
I'm gonna just show you the right solution. Okay.
I don't mean to cut you off, but I had a problem with that too, and it was because I didn't put dollars behind it, and it
Oh,
put dollars.
Oh, that's why. Oh,
Yeah,
shit.
it wants you to
well,
put
thank
dollars.
you so much. Thank you so much.
Yeah, why they ain't just say that though? They
Yeah,
kept
And then there
saying
was
like
like,
that.
there was
I
another
did
one with the
5 times. You
sequence.
said it's incorrect.
Yeah,
Yeah. I
there was
knew I
another
was right
one.
though.
Yeah, there was another one with a sequence on somewhere.
Dollar
It was
sign.
like 3 problems. You had to like put it alphabetically order. I didn't get that. I was like, oh, okay. But
Yes.
yeah,
All right, thank you so much.
you're welcome. Like the word dollar, not the
The
dollar
word
sign.
Oh, I appreciate you.
I tried it 20 times.
Yeah, the word. Yeah,
dollars, right? Let's see.
yeah. You got to put dollars.
Actually incorrect. And you see this dollar without S.
Hold on, let me see what I put.
Wait, hold on. I gotta type the word dollar,
Yeah, I put dollar.
capital D or lowercase d.
Hold on, I'm about to check. Hold on.
I'm sorry.
Now you fine.
Yeah. No, the number is not right. Okay. It's
Oh.
no, it's yeah, this is not right. I saw. That's a problem here. There's a little it's not 130, right? Okay, so I'm gonna solve it anyway. That's the reason. But you got a good point though.
It is not 130.
No,
You
it's
got to
not
do
130.
negative. With mine, it was negative $30. I put lowercase DOLLARS.
Okay.
The one I had.
So
Yeah,
it's
my answer,
negative.
my numbers was all different, but my answer was a negative answer, and I
Yeah,
kept
mine.
putting it. I'm like, yo, what's going on? Like,
Yeah, mine was
whole
negative.
time missing dollar.
Okay.
Yeah, you got to put dollar. Hold on.
I'm gonna solve this one, right? I'm gonna
Wait. So it's negative $30.
Wait, mine is different. I have different numbers. Let me.
everybody has
Yeah,
different
everybody
questions.
numbers is different.
Oh, bad laws.
So you gotta base on your own number, right? I'm gonna solve this.
Can we, Professor? Can we do this question together as a group?
Yes, I'm gonna go over this right now. Yes. Okay.
All right, thank you.
Sure. So you guys all understand this problem. Okay, so first of all, they start with the minus 390, right? Then they charge $30 overdraft fee, meaning you're gonna subtract $30 again.
It's
Then on
negative
January, yeah. Right. Question. So after that, they will deposit $800. So add 800 to your account. And then after that, you withdraw $650. So now you're gonna combine those two negative numbers first. So keep the negative sign, adding 390 and 30, you get 420. Then adding 800 minus 650. If you want, you can combine those two numbers, right? No problem, because for addition subtraction, they're in the same range. So you can actually combine any two. 800 minus 650 is 150. Now, you have 150 minus 420, smaller number minus bigger number will be negative. 420 minus 150 is 270. So it should be minus $270 for Gavin's question. Okay. So it's minus. I'm gonna put in dollar sign, see what happens. Minus dollar sign 270. That's, I think that's what they want. Yes, that's good. And also you can put a, I think maybe
That's nonsense because it wouldn't go through if you put the word dollar and I put the stupid little money sign thing in front of it.
yeah, right. You gotta put the the dollar sign in front of this. Yeah.
I did that. It don't go.
Right. It's yeah. This question is not worded. It's not worded very clearly. But if you look at the solution, do you guys have access to the solution?
No.
No. Oh, okay. I see. So if they do put a dollar sign in front of it, it's 270. But it's okay, right? You know what happened, you know. So but definitely, if you have any question, you know, in your homework, let me know, right? If you try several times, maybe couldn't figure out, bring to the class. Go over that. I'll go over that in the class. Okay. Now go back to this this part, right? To the previous question. Okay, let's go back to that. I solved that one. I'm gonna go all the way back to the previous question. Next question 4. Okay. So we're on this 2.1. Simplify expressions. Now it's question 3. We did it. Problem 4. This is the one. All right, so that's it. Let's go over this question right here. So first of all, you will distribute this, right? So minus 10p times 1, and it's minus plus is minus 10p times 1 is 10p. Then the other one is the minus 10p times 5p squared. So minus plus is minus 10 times 5 is 50. Then p times p squared, right? P to the first, p to the second, so it's p1 plus 2, p to the third. So you get 50 p cubed. Now we get, there's a couple like terms, right? So you're gonna combine that. So these two are like terms. Combine them 6 minus 10, smaller number minus bigger number, negative 4, right? And minus 50 p cubed. Okay. And that's correct answer. Any question about this?
Did the one just disappear?
Oh yeah, you mean which one?
The one that's in the parentheses.
In the parentheses? Yes, because any number, right? Any number times 1. Any term times 1.
Oh, sorry, my fault.
Right? Yeah.
So it doesn't matter with the variable, right?
Yeah,
Like anything that's in parentheses is getting multiplied by the number that's outside.
Right, exactly. So anything, right? If you multiply anything by 1, it stays as this, right? Nothing changes. So it's the same thing. That's a 1 is a very magical number, you know, and you multiply anything by 1, you get itself. Okay, so that we get minus 4p minus 50p cubed. So we combine like terms, minus 4p minus 50p to the third power. If you want to get exponent, you can click on this one, right? Type in p first, then click on this one, exponent, to get exponent. And then you can check the answers. It's correct. Now let's look at this one, right? Use the order operation to simplify. So you can put that invisible one here if that helps. And do this, right? Do 6, do -1, and then combine that terms afterwards. I'll actually try really quickly. All right, guys, let's go over the solution. First of all, you distribute 6 to the 3x. 6 times 3, 18. And 6 times positive 4 is 24. Positive. And then one way to look at it is I multiply -1 by 5x. Negative positive is minus 5x. And then -1 times -9. 2 negative turning positive. 1 times 9 is 9. Now we're gonna you can switch between terms, right? So 18x minus 5x first, adding 24. We're gonna combine those two terms. You get 18x minus 5x is 13x. 24 plus 9, that's 33. So the answer is 13x plus 33. Any question about this? Okay, so correct answer. All right. All right, so this one you gotta follow 10x, right? You go to the innermost parentheses first and distribute this, simplify, and then gradually move outside. You can try this one. Let's go over the solution. So first of all, go to most innermost parentheses right there, and then distribute 6 to both terms, and then carry over everything else. 6, 3, 7x, and now 6 times 3x, we get 18x. Then 6 times positive 6 times -5 plus minus is minus 6 times 5, 30, and minus 3. Now only have one parenthesis left. Now inside parentheses, we're gonna combine like terms by constant. So 6 plus 3, 7x plus 18x, that's 25x. And then minus 30, minus 3, minus 33. Now from here, we're just gonna distribute this. We get a 6 plus 3 times 25x is 75x. Plus minus is minus 3 times 33, that's 99. Now again, we still got to combine those two constants, right? So 6 minus 99, we carry over 75x. 6 minus 99 is minus 7. So the final answer will be 75x minus 93. Any question about this? Okay, so that check the answer. Yeah, it's correct answer. Okay, so now let's talk about okay, let's continue from here. This is section, we just went over section 2.1 homework. So next thing is addition property of equalities. Right? We can talk about this. Meaning we're going to use this to solve the equations. Equalities. So basically, if let's say we have equation A equal to B, right? Then if you're adding C on both sides of the equation, then we still end up with the equation here, right? Although it's a different equation, but we still have the same, we still have an equation. Meaning adding the same number to both sides of the equation will not change the equation. Adding the same number, it gotta be the same number, right? Same C, same number to the both sides of the equation. Does not change the equation. Will not change the equation. All right, so for example, let's say we have something like 3x minus 1 equal to 8, right? So in order to solve this equation, we get the first of all, we're gonna add the number, right? In this case, in order to isolate 3x, you add 1 from both sides of the equation, right? And then, yeah, so we cancel that to the end of 3x. Right? And from there, if we divide both sides of the equation by 3, then we get a solution, right? So cancel the 3. X equal to 9 by 3, that's 3. So that's how we apply this addition property of equality. Right? We also have subtraction property. Of equality. So again, if A equal to B, right? We got an equation here, and then if you subtract C from both sides of the equation, and it does not change the equation, right? So still we get this kind of equation, but slightly different equation. And then we also have a multiplication property. Maybe let me quickly give you an example here. Example, let's say we get something like x plus 5 equal to 9, right? And in order to get x by itself, you're gonna subtract 5 from both sides of the equation. And then once you do that, then x is by itself, that's what we want. 9 minus 5, that's 4. Then we figure out the variable x, right? The value of the variable x. Sarah, question?
So when you're adding, you're actually subtracting, and when you're subtracting, you're actually adding?
Yeah, exactly. The opposite, right? You're doing the opposite. Very good.
Okay.
It's a very good observation. So you see, this is minus, we do plus, right? Opposite. This one is plus, we minus. Based on the need, right? Based on the goal is to keep x by itself, right? To get x by itself. Yeah. And then multiplication probably of equality. Again, let's say a equal to b. Now you can multiply both sides of the equation by c. A times c or b times c. Right? It's still gonna end up with the equation, slightly different ones, right? So for example, let's say we have something like, we use a very simple example. Let's say 1/3 of x equal to 5, right? Now here we get a 1/3, meaning we want to get rid of 1/3. So one way to do it is multiply both sides of the equation by 3. 3 times 1/3 is 1, right? You multiply 3 on the left, you multiply 3 on the right. And then on the left, 3 and 1/3, they cancel each other. They are reciprocal. Now x is by itself. Now 5 times 3, that's 15. So again, it's like reciprocal, right? It's like the sort of like the opposite. Like it's 1/3, but we multiply by 3. And then also the division property of the equality. Now, once you master all those 4 properties, now you can solve basically any equation, right? Any linear equation with one word. Again, if a equal to b, then a over c. You're dividing a by c, and then dividing b by c. Assuming c is not 0, right? We end up with a different equation, but it's still the equation. So for example, let's say we have a 7x equal to 49, right? Something like that. And in order to get rid of the 7 here, so we're going to divide 7x by 7, get rid of the coefficients, 49 by 7. If we cancel the 7, then x is by itself, 49 by 7, that's 7. Okay. Any question about this? Now let's take a look at some of the questions here, right? Let's say we have an equation down here, x minus 5 equal to 12. Right? Let's see that.
Wait, Professor, could you just scroll up just a little bit?
Sure, yeah.
Just right, yeah, right there.
Okay.
Right there. Thank you.
Yeah, sure, definitely. Now for this particular problem, in order to isolate the x, then you need to add 5 on both sides of the equation. And then once you cancel the 5, right, they are opposite, so they offset each other. It's equal to 73. I'm also going to show you how to quickly check it. You also check it, right? Check the solution. So meaning when x equals 17, I'm going to plug into the original equation. See left hand side equal to right hand side. So 17 goes here. Then get 17 minus 5 on the left. We don't know whether or not they equal to each other. If you have the correct answer, they should, right? They equal to each other. But if you end up with the incorrect answer, then left hand side is not going to be equal to right hand side. So right here, we plug in 17, 17 minus 5 is 12. And 12 is the same thing as 12. That means this is good. The answer is good. And that's how you double check the answer is good. And then secondly, Let's say we have something like a plus 3/4 equal -half, right? Although it's a fraction, right? We get a fraction here, but still we're gonna treat it like the regular numbers, right? So just again subtract the 3/4, right, from both side equation. And then on the left, we cancel the 3/4, and a is by itself. On the right, we can have half minus 3/4. Here is a fraction, so we're gonna use LCD. LCD is 4, right? Because 4 is twice of 2. Okay, so that means 4 must be the LCD. Now we can combine them by multiplying first fraction by 2 on the top and bottom. Second one minus 3/4. Now a equal -3/4 minus 3/4. Now we're gonna keep the sign, right? 2 negative, keep the sign. Now combine those two fractions. Adding 2 and 3, we get 5/4. So the answer is -5/4. And you're gonna check it, right? You're gonna check the solution. Check the solution. A equal to -4. And going back to the original equation, 3/4, we want to make sure left hand side equal right hand side. So now you're gonna plug this fraction into the equation. On the left, we get -5/4 plus 3/4. We don't know yet, so put a question mark on top. Now, if you combine them, it's like, let's say, like fraction, right? So we know they are like fractions, so you can just combine the numerator. -5 plus 3, that's -2. But bring over the 4, right? So -2/4. We don't know yet, but when we reduce it, we know it's the same, because both 2 and 4 could be reduced by 2. So 2 by 2, you get 1. 4 by 2, you get 2. -half is same thing as -half, right? For sure. So that means we check it. This answer is good. This is good. And usually you should always check it, because when it gets very complicated, right? There's a chance you are making mistake along the way. So by checking the answer, you'll be able to provide some assurance you have the correct answer. Okay. And any question about this?
Yeah, why did we automatically multiply 1.2? I mean, -1/2 times 2 on both sides of the fraction.
So
you
can
see
do that. If you want to turn everything into, I see what you mean, right? So if you want to turn, Corinne, so basically, if you want to turn everything into whole number, now you're going to use LCD. So instead of using 2, you're using 4. That means you're going to multiply 4 here, multiply 4 here, multiply 4 here. Does that make sense?
Okay, I got you.
Yeah. If you do that, that's fine, right? So we get 4a plus, and then cancel the 4, right? We get a 3. And here, we go into 4 2 times. -1 times 2, that's -2. Now you could, yeah, once you do that, then you can subtract 3 from both sides of the equation. And you get 4a equal -5. And you divide 4 from both sides of the equation. And a equal to -5/4. So basically, Corinne just provide another way of solving this type of problem. If you guys like to follow this type of, if you want to get rid of the denominator, you don't want to deal with the fractions, this is the way to go. But again, you're going to use LCD, right? If you're using 2, that's not help too much, right? It just partially help us, but you still got to deal with the fractions. But once you use LCD, then you completely avoid the fractions. I know a lot of you guys, don't feel like dealing with the fractions. Yeah, so that's this is the way to go. Yeah. Okay. Very good. Very good. Very good point. Yeah. All right. And now let's look at. Let me show you a little more sophisticated one. So, for example, we haven't done anything with the decimal yet, so let's deal with one of the decimal numbers. So let's solve for this decimal. Let's say 7.3 plus x equal to -2.4. So we have a fraction one, whole number, fraction, decimals. And for decimals, you just subtract 7.3 by using the opposite on both sides of the equation. Cancel that and x by itself. Now you combine two decimal numbers, keep the sign. Now 4 plus 3 is 7. Bring over the decimal point. 2 plus 7 is 9, right? So the answer is x equal to -9.7. Now if you check it, you're going to plot x equal to -9.7 into the equation, so 7.3 plus x minus 9.7. We don't know yet, -2.4. Then get plus minus is -7.3 minus 9.7, -3.4. And then we get smaller number minus bigger number, that's going to be minus 9.7 minus 7.3, that's 2.4. We just verify left hand side or right hand side, right? This is good, reference answer. Good. So that's basically how we check it. So now next thing, I want to show you a little more sophisticated ones. So let's say we get something like this. Solve 4 times 2a minus 3 minus 7a equal to 2a minus 5. So if you look at it, we get the variable a all over the place, right? Some on the left, some on the right. Also numbers on the left, on the numbers on the right. So first of all, we're gonna solve for a here. Solve for so distributing first. So we get 4 times 2a, that's 8a. 4 times 3 plus minus is minus 4 times 3, 12 minus 7a equal 2a minus 5. Now combine like terms, right? 7a minus 7a, those two are like terms. So get a minus 12 or 2a minus 5. So now you could make it. You can make a decision whether. Now next thing we're going to move this a. We're going to combine those two variable terms, right? A with a. So one way to do it is you can subtract a from both sides of the equation, right? Because 2a is bigger than 1a. So by doing this, we can avoid the negative coefficient. So here cancel a minus 12, 2a minus 1a, that's 1a, right? 5. 2 minus 1 is 1. Now we have 5 from both sides of the equation, then get a result, right? So we get 1a equal to, and we can omit that 1, we don't need it. Usually, this again is really invisible 1, so we don't have to put it there. It's not necessary. So we get a equal to minus 12 adding 5, that's minus 7. And eventually you're going to switch it, a equal to 7. Yep. So that's how you solve it, right? Sometimes we get a little bit more complicated. And also you're going to check it, right? Check by plugging the numbers into the original equation. We get 4 times 2 times 7 minus 3 minus 7 times -7. We don't know yet, question mark. And 2 times -7 minus 5. Now from here, we're going to multiply those two. So 2 times -7 minus 14 minus 3. And here's the -7 times positive -7, 2 negative is positive. 7 times 7 is 49. On the right, 2 times -7 is -14 minus 5. Now combine those two numbers, right? Keep the sign, adding 14 and 3, 17, plus 49. And on the right, -14 minus 5 minus 19. Keep the sign, add the numbers. Now 4 times -17 plus minus is minus. 4 times 17, 68, added 49. As you can see, 49 minus 68, that's minus 19. So the left-hand side or right-hand side, this is good, and then the answer is good. Any question about this? Yeah, so now let's get to our homework platform. Let's do some practice on this section, solving the addition property. Let's start with the addition properties. There's only one problem here, so let's do it. Okay, solve each one of the equation, solve for x, y, and then a. Let's do it. All right, let's go over the solution. So the first one, we're gonna use subtraction, right? Subtraction property. So subtract 2 from both sides of the equation. Then x equal to 11 minus 2 is 9. And this is a fairly quick check, right? 9 plus 2 is 11. So it's good. Solution is good. Y minus 6 equal to 9. I'm adding 6, right? Addition property, opposite operation, right? Always. So cancel the 6, y equal to 6 minus 9 and 3. Minus 3 minus 6 is minus 9. So that's good. I skip that. Skip the check. And minus 6 equals minus 5. 6 from both sides equation. A is equal to 6 minus 5, that's 1. 1 minus 6 and 5. So we have the correct answer 9, 3, 1. This is very straightforward. Any question about this? Okay, 3 and 1. So good. Yeah, so this is the only question in the section 2.2 homework, right? So let's go back. It's about addition property. Next one is multiplication property, right? So let's look at it. 7 question here. Let's start with this one. You guys try this one. Okay, let's go over the solution. So this question, first of all, we're gonna get rid of the 14 on the left by adding 14 from both side equation. So we cancel the 14, the 10x equal to 20 plus 14, 34. I'll divide 10 from both side equation. I'll cancel that, x equal to 34 by 10. Right? They both even numbers. So you divide 34 by 2, you get 17. 10 divided by 2, get 5. You can leave the answer like that. If you want a mixed number solution, then you would do big long division. 17 over 5, 3 times 5, 15, remainder 2, right? So 17 over 5 is the same thing as 3 over 5. 3 and 2/5 if you want a mixed number solution. And then let's check it. This one we need to check it. So 10 times 17 over 5, replace with a 17 over 5, minus 14. We don't know yet, so let's do that. I make a fraction 5 going to 10 2 times. And 2 times 17, 34. 1 times 1 is 1, minus 14 equal to 20. So it's 34 minus 14. It is equal 20. Right, so this is 20 equal 20. So that means that this is the correct solution. 17 over 5. Right, any question about this?
Yeah, Professor. I didn't get a fraction. I got a decimal. I got 3.4.
Yeah, 3.4 is good. If you put
Okay.
in 3.4, 17 over 5 is 3.4. That's totally fine, right? You get it correct, you see?
Okay. All right.
But if you put in 17 over 5, it's also correct. Yeah, definitely. But not every fraction could be turned into a decimal, right? If let's say it's a 17 over 3, then you're gonna get 5.333, no, 5.6666666, right? So that's not a, so you can't turn into a decimal fraction, correct? Yeah, it's the same thing as 3.4. It's as equivalent to the one just submitted. Okay, very good. Now, next question, problem 2. Let's try this, right? All right, guys, let's go over the solution. So 3y minus 2, 2y. First of all, we're gonna combine two variables, right? So in order to do that, you're gonna subtract 2y on both sides of the equation. And it's easier this way. You can also subtract 3y, but you're gonna have to deal with the negative fraction, negative coefficient, which is not convenient. So usually we move the smaller variable term to the bigger side. So you cancel the 2y, 3y minus 2y is y, 1y minus 2 equal to 13. Now using addition property, adding 2 on both sides of the equation, and 1 equal to 2 minus 13 is minus 11. So the answer should be minus 11, but we can quickly check it out just to make sure it's good answer. So let's do 3 times 11. 2, we don't know yet. And the 2 times negative 11 and 13. Now, it's really, you get minus 33, it's 2. On the right, minus 22, right? 2 times negative 11 plus minus is minus 2 times 11, 22, 14. And it's negative 35 on the left, negative 35 on the right. They do equal to each other, so this is a good answer. So y equal to negative 11, it's the correct answer. Any question about this? Should be the correct answer. Our next problem. Okay, you guys have this one. All right, guys, let's go over solutions here. So carry over a1 12 equal to 12y minus 18. So you could do either way, right? the easier way is subtracting AY both sides equation. Because AY is smaller than 12y. 12 is bigger than 8. So by doing this, we avoid the negative coefficient to cancel that AY. 12y minus AY is 4y minus 18. And from there, we just add 18 from both sides of the equation. And once you cancel that, you get 4y on the right. On the left is 18 minus 12, 6. Right? Now you can, if you want to reverse it, you can reverse 4y over 6. I'll divide both sides of the equation by 4. So you get y equal to 6 over 4, and then you reduce it 6 by 2, 4 by 2, right? 6 by 2 is 3, 4 by 2 is 2. Or you can also write it as a 1.5. This one is evenly divided, so 1.5 works. And that quickly check it. Right here, put back 3 over 2, right, into the original equation. So 8 times 3 over 2 minus 12, you're going to what? So 12 times 3 over 2 is 18. And make the fraction here, 2 going to 8, 4 times. So on the left, we get 12 minus 12 over 1, that's 12 minus 12, 0, right? On the right, 2 going to 12 is 6, and 3 times 6 is 18 over 1, 18, minus 18, all 0. Left hand side 0, right hand side 0, so this is the good answer. Correct answer. So any question about this? Answer is 3 over 2. Yeah, that's correct. 8.5. Yeah, so let's see if you can deal with the decimal ones, right? This one has a decimal. Let's try it. All right, guys, let's go over the solutions here. So first of all, you're gonna combine like terms on the left-hand side. So you get 0.2 minus 0.08. And so you subtract it. So carry up, borrow 1 from 2, right? You get 10 minus 8, that's 2. And this one becomes 1, right? 10 here, 1 minus 0, that's 0.12. Bring over decimal point, bring over 0. 12x. So 12x on the right, it's really. So you're gonna get 1.12, right? Times 0.62. And you're gonna multiply them, by the multiplication rules. So 6 times 2 is 12 over 1. 1 times 6, 6, adding 1, 7. 6 times 1, 6. And 1 times 2 is 2. 1 times 1 is 1. 1 times 1 is 1. I get 2, 9, 7. And the 2 decimal here, 2 decimal here. Combined total is 4 decimal, right? So the answer to have 4 decimal. So this is going to be 0.1792. So you put 0.1792. And do that. The other one, 0.6 times x is minus 0.16. On here, we're just going to add in 0.16x on both sides of the equation. And move move this one to the left hand side. So 0.12 adding 0.6 means 0.28. 0.1792. Now I'm gonna get rid of the coefficient by dividing 0.28 on both sides of the equation. So that now x is by itself. I'm gonna do the long division, right? 172 0.28. Now you divide this, you're gonna move this 2 decimal for the divisor, 2 decimal to the right, make it 28. And you're gonna do the same thing for the dividend, right? Move the decimal 2 units to the right. So basically we get 17.92 over 28. This is equivalent division. Now we're gonna divide it by from here. So 20 go into 17 0 times. Now we take 3 digits, 179, 28 going to 179. Let me see, 9 times 5 is 146 times, right? 6 times 3, 48, and carry forward 168. Subtract it, you get a 112, right? 28 going to 112. That's 4 times. 4 times 28 is 112. Okay, so the answer is 0.64. And we could double check it, right? If you want to, we could definitely check this by. So we can check it. So 0.2 times 0.64 minus 0.08 times 0.64. And on the right, we get 0.16 times 1.12 minus 0.64. Not enough space, so 1 second. We leave a little bit more space, so I'm going to move this a little bit. So 0.2 minus 0.64 minus 0.08 times 0.64 equal to 0.16 times, we don't know yet, 0.12 minus 0.64. So if you want to save some time, right, you can factor out 0.64. Then it's 0.2 minus 0.08. That's on the left. And on the right is 0.16 times 1.12 minus 0.64, that's 0.58. Okay. We don't know yet. So it's 0.64 times, this is 0.12. I just multiply twice, right? So we get 0.64 times 0.12, 2 times 4, 8, 2 times 6, 12. 1 times 4, 4, 1 times 6, 6. This will get 8, 6, 7. And total 4 decimals, so 0.0768. On the right, we multiply 0.16. No, that's 1.58 first. It's slightly easier. You put 0.58, it's 0.16. 6 times 8, 48. 34 over 6 times 5, 30, adding 4, 34. 1 times 8 is 8. 1 times 5 is 5. So get 8, 12, carry 1 over. That's 8. No, it's not the same. Yes. The result is not the same. Okay. We made a mistake somewhere. 1.6, 1.12 minus 0.64. Oh yeah, it's 0.48. My bad. That's it. Yeah, this is actually 0.48. Right. So that we do this. I will look. So we do this quickly. Then going back here, and let's multiply 0.16, 0.48 times 0.16. Yeah, that's correct. Yeah. 6 times 8, 48, 34 over 6 times 4, 24, adding 8, 428. 1 times 8 is 8. 1 times 4 is 4. Take 8, 16, get 1 over 7, so it's 0.0768. Right hand side is the same thing as left hand side. Yeah, so it's good. No question mark needed. It's good. All right. So we just freely check it. So this is the correct answer. X equal to 0.64. Any question about this? All right, so let's take a break. Okay, I'm gonna quickly double check first. So come back at 10:50, right? At 10:50. Okay. All right, guys. Let's have a break. In 30 minutes. I see you guys in 30 minutes. Okay, let's go over the solution. And this question is second on both sides of the equation. The 7x to 3 minus 10 is 7. About 7 on both sides of the equation. X equal to 1. So you can plug in the numbers to check the solution, but I will skip that. Let's look at assignment 1. Okay, let's try this one.
Professor,
Yes.
is there any tricks that you can give us to like remember how to divide fractions?
How divide fractions? Yeah,
Yes.
sure. Definitely. How to divide fractions. So like this one, actually, you're gonna use like the second one, right? So okay, so we're gonna use the second one as example. 6 over 7x equal to 5 over 4. So instead of dividing, 6 over 7 from both sides of the equation, you just multiply by the reciprocal, right? So anytime we have a fraction, you can always multiply by reciprocal. Meaning flip top and bottom, get a reciprocal. That's what. On day one, I show you guys reciprocals. This is very, very important concept. And when we handle the fractions, reciprocal becomes very useful. So basically, reciprocal A over B becomes B over A. And then the product of the reciprocals, right? A over B times B over A, it becomes 1. And so we can easily get rid of the fraction on the left-hand side by multiplying by reciprocal. On the right-hand side, very similar, multiply by 7 over 6. Same. On the left, you see 6 cancel, 7 cancel, and becomes 1. So x is by itself. On the right-hand side, 5 times 7, 35. 4 times 6 is 24. You can leave it like that. We cannot simplify. this is the best we can do. So the answer is 35. 20.
Oh, I feel like I knew that. I think I just had like a brain fart.
Also, you can divide, but you're gonna deal with the long division. You can divide like 6/7, right? And then cancel it because we divide by the same fraction, so cancel that. X is by itself. Now the thing is, you're gonna turn this division into a multiplication between. So bring over 5/4. And then on the denominator, you flip the top and bottom. So again, we are using the reciprocal, the 7/6. But it look a little bit more complicated compared to the multiplying by reciprocals because it's more straightforward. So 500.
Yeah, I remember now. Thank you.
Okay, no problem. Okay, very good. Any other questions, guys? 24. So the first one, 2x. To divide 2 from both sides. X is equal to 5. And then the last one, C, we're going to divide the decimal 0.35 on both sides of the equation. So divide 0.35 here, divide 0.35 here. Yeah, so we're going to cancel this 0.35 on the left. And that one we're going to use a long division. So maybe we should. I don't think we can divide it evenly. Let's try it. So 0.375 over 100. First of all, move the decimal 2 units to the right for the divisor. Now we're going to do the same thing for the division, like the decimal 2 units to the right. And then with 37.5 by 35. Let's say 35 going to 37 one time. 35, that's 35. Remember 2, now you copy the decimal, put in the quotient, bring over the 5, and add a 0 in the back, right? Because 35 doesn't go into 25, so 0 times. Now bring down another 0. Now 35 going to 250, that's going to be 6 times, 7? Yeah, 7 times actually. 7 times 5, 35. 33 over 3 times 7, 21, and 3, 24. Like a remainder 5. That's not, it's not evenly divided, right? I can see that. It's not going to be even. Maybe it is. Let's see. 50. And add another 0, right? Bring down that. 35. Remainder 15. Add a 0. Nope, it's not evenly divided. So you're probably not going to use this, right? So I'm going to show you how to turn this into the fraction form. So basically you just move the decimal 3 units to the right, for the denominator, for the numerator, both numerator denominator. So move decimal 3 units to the right, move decimal, add a 0 in the back, move decimal 3 decimal to the right. And now with 375 over 350. Because we cannot turn into a decimal property, we're going to have infinitely many decimal places. So it's not a good idea to do that. That's why we're going to stick with the fractions. So yeah, so basically 375 over 350, we can divide both top and bottom by 5, right? Because one ends with a 5 and one ends with 0. So 375 by 5, 350 by 5. So we get x equal to 375 by 5 is 75. 350 by 5, that's 70. Yeah, that's right. Okay. And we're going to keep reducing, right? We have to divide 5 again. So that's equal to 25 over, yeah, that's 25. And that's 8. 5 and 14. 25 over 14. No, 25 by 5 is 15. It's not 25, it's 15. So the answer is 15 over 14. So So any question about this? 5 here. Another one 35 over 24. Last one is 15 over 14. That should do it. Let's say, and let me try, by putting decimal numbers 1 to 3 decimal places, see if it takes this answer. It does actually. You see, remember I did, but again, theoretically, I leave as 3 decimal place here. It takes it though. But no, the proper, better answer would be 15 over 14 because that's the exact answer. All right, so next, last question, right? Let's talk about this last question, and then I'm going to show you some more practical way of solving the linear equations. Okay, let's go over the solution. So right here, you can add 8x on both sides of the equation. Okay, so we cancel the minus ax by opposite turn on left. 8 minus 6x plus 8x is 14x. And 3. Now that's 3 from both sides of the equation. Then 14x is by itself, right? That's what we want. And then you can switch the order, right? Writing 14x first, and for the 11, now very last thing, divide 14 for the side equation, and we get a result, right? So the result is x equal to 11 over 14. Any question about this? 11 over 14. So again, these are all basic ones, right? I want to get to some comprehensive ones, like this one, which did 3.2 tuition. The next one is solving more comprehensive linear equations. Let's look at this one. Okay, what if they are fractions? So try this, right? one way to do it is find LCD, multiply every single term, right, by LCD. That could be a way to avoid the fraction. Right? Let's try this. Here's the LCD, right? Let's see what the LCD is. Okay, I'll let you try it first before I show you the answer. And so for those three numbers, 3, 4, and 6, okay, the LCD is going to be 12, right? You can also do this. Let's say the common multiple of 3 will be 3, 6, 9, 12. And then for 4 is 4, 8, 12. For 6 it's going to be 6 times 1 is 6. 6 times 2 is 12, right? You see when three numbers reaches the same number first time, that's LCD. This is another way of looking at an LCD, right? To get all the common multiples. And then the smallest value we are reaching for all three groups. And that's going to be the LCD we are using. So LCD is 12. And once we know the LCD, then we're going to multiply every single term LCD. 1/3 of that. 3/4 times 12. And then 12 times 1/6. And 12 times 1/4. You want to make it easier, so make it fraction. Then you can simplify, right? 3 going to 12 4 times. And this one becomes 1, and then 4 going to 12 3 times. This becomes 1. 6 going into 12 2 times 1. 4 going to 12 3 times. So 4 times 1 is 4 over 1 4x. This one 3 times 3 9 over 1 it's 9. And 2 times 1 2 over 1 2x. And last one is 3 times 1 3 over 1 3. Now you see no more fraction, right? It's all gone. So you get a brand new equation with only whole numbers. So you just subtract 2x from both sides of the equation and get 4x minus 2x minus 9 equal to 3. Now add 9 from both sides of the equation, and then 2x equal to 4. Now divide 2 from both sides of the equation, the x is by itself is 46. Okay, any question about this?
So when we find the LCD, you have to multiply it by every fraction.
Yes, exactly, Maya. That's what you're supposed to do, right? You're gonna multiply every single term by the LCD. You can only do that, right? Otherwise, you're gonna break the balance of the original equation. Only if you multiply every single term by 12, then the equation remain balanced. Okay. All right. Any other question? Very good. Now the answer is 6, right? So you're just gonna put in 6 and check it. Yeah, it is correct answer. Now I'll try another one, right? This becomes a little more sophisticated. Okay. Try this. Okay, let's go over the solution. So we're going to simplify this parentheses first. So we're going to distribute -7 to 2x, -7 to +6. So carry over -11, -7 times 2x minus plus is minus 7 times 14 in the next. And -7 times +6 minus plus is minus 7 times 6, 42. Adding 7x. I'm going to combine like terms, right? Those two are like terms. And combine constants. So for the variable class, 7x minus 14x is 7x. And 3 minus 42 is 19. Okay, and from there, and minus 7x, right? 7x minus 14x is negative 7x. That's a very common mistake. Sometimes you just forget to bring over the negative sign. So if you want, you can just do this. 3 minus 42. Switch them, that would be a little bit easier. Like that, and then we combine two groups separately. And so we get minus 7x minus 39, and then 39, both side equation. Okay. Cancel that 39, with minus 7x to 39 minus 11, that's 28. From there, we divide -7 from both side equation. So we cancel -7. X is by itself. Is it plus minus? It's minus. 28 by 7 is. So the answer is -4. Okay, any question about this? Oh, I checked it. You should be good. Now, third question again is with the fraction, with the decimal numbers. Let's try one more. All right, let's go over the solution. First of all, on the left-hand side, I'm going to combine those two variable terms. So minus 0.48, 12, a minus 2 is 6, a minus 1, 3. And then decimal point 36x. The right distributed, I'll get a 0.08 times 2.2. So 0.08. So I think it's easier doing another way. 2.2 times 0.08. 16 adding 1 over 2 times 8, 16 adding 1, 17. In total 3 decimal places. 1 here, 2 here, 3. 0.176. Distributed 0.08 times negative x is minus 0.08. And now from here, we just combine both variable terms, right? 0.08 adding 0.08. And so that you get 0.44 equal to 0.17. Now divide both sides of the equation by 0.50. And so that x is so get 0.176 over. Yeah. Now move the decimal here 2 units to the right. 2 units to the right, 2 units to the right. Right, so we turn into 17.6544. Then first of all, 44 going to 17 0 times, and then copy the decimal point, put in the quotient. 44 going to 176 will be 4 times. 4 times 44, 176. Nope, it's not. Okay, 1 second. It's actually, is it 4? Yeah, actually it's not 4, it's 6, right? No, not 6. 44, 3 times 132. 4 times, yeah. Yeah, 4 times is 176. 4 times 4, 16, right? Carry on over 4 times 4, 16, adding 176. So we get that. So when you subtract it, it's 0. So the answer is 0.4. All right. Any question about this? Yes, Maya.
How come it didn't turn positive inside the parentheses if 0.08 is positive?
0.
I thought you said it's going to turn whatever the number is outside, whether it's negative or positive, turns the equation.
No, only if it's minus. Here it's plus.
Only
Right?
if it's negative.
So it's because by default there's no positive sign here, but it's positive. Positive 0.08 and plus minus is minus. Probably get minus here.
Oh, okay.
Times minus is minus, right?
All right.
Yeah. Okay. Okay. So that's yeah. Although it's a little thing, right? But it's very very important to understand this in details, so we're not making mistakes. If you make mistake anywhere, right? Even with the sign and the result, the final result will be totally off. I'm glad you asked a lot of very good questions. So 0.4. So answer is 0.4, and let's check it. And also, we're gonna learn how to solve the linear equations with using the formulas, right? So let's look at some of this. Actually, I already went over some of the formulas, like those rectangle parameter, and then also the area of the rectangle, and then square, triangle, also the circle, right? Those are the useful applications in this. So let's take a look at some of the formulas, see how we deal with the formulas in terms of solving this. And this one, use this formula to find y if x equals 15, right? So here we're going to replace x with the 15 and then solve for y. Okay, so let's try one of this. Give a couple minutes. Okay, let's go over the solution. First of all, you're going to replace x with a 15. And from there, we get a 3 times 15. y equal to minus 22. And here, we only have one variable, right? We're gonna isolate minus 5y, so multiply those two numbers first, 45 minus 5y equal to 22. Now that minus 5y by itself, so we do the opposite, is 45. Once you cancel 45, then we get minus 4, 5y equal to, we're adding two, this is adding, right? Adding two negative numbers, keep the sign, add those two numbers, right? By face value. So 2 plus 5, 7, 2 plus 6. Now divide both sides of the equation by negative 5. Cancel that, and x by itself, that's what we want. Two negative turn positive, but we don't write it, right? Positive sign usually you could omit it. 67 over 5. So the answer is 67 over 5. And yeah, so that's the answer we're looking for. Any question? Okay, let's check the answer. It's the correct answer. Next thing, right? Now we have a variable. Before we get started, I'm going to show you a formula. We're going to learn how to solve it first. So this is a typical one we are solving for V here, right? But let me give you another formula here. So a lot of formulas. So there's another formula called cylinder. Let me say we have a cylinder here. Well, so there's that's so the volume, so the surface area, right? That's for this. That's a circle on top. So that will be radius r, height is h. So will be surface area is pi r squared 2 times pi r squared plus 2 pi r, right? Which is the perimeter of this cylinder, and then that will be 2 pi r times h, right? And then here, if we want to solve for variable h, how do we do that? And then let's solve for h. So typically, anytime when you have a formula, some formula like this, you basically isolate. You're gonna isolate this part. So let's reverse it. So 3 pi r times h plus 2 pi r squared equal to s. So step number one. So let's switch the formula first, right? And then after that, we're gonna isolate this. So subtract 2 pi r squared from both sides of the equation.
Are you writing something?
Yeah. Oh, did I forget to I forget to share that. Yes, I write it all. Okay, so I'm gonna start over, right? Since I didn't explain this too much. So this is a formula for the surface area of this, we call this cylinder, right? It's a typical cylinder. Okay, so we get this cylinder here has two circles, one on top, one on the bottom. For those two circles, the area is pi r squared, right? But we get two of them, so we get 2 times pi r squared. That's how we get the surface area for the top circle and the bottom circle. And also we have a area surrounding the cylinder, right? And that one, if you can visualize this, we can actually use a scissor, right? Cut it, and then you will turn this into a rectangle. Actually, if you open the top circle, open the bottom circle, stretch it, right? You're gonna see this. You will form a rectangle shape. So on the top, this is basically perimeter of the circle, right? The perimeter is 2 pi r. And then the height is h, right? So we know for the rectangle, the area is equal to side by side, right? 2 pi r times h, and that's how we get this. Now the question is, in this formula, right? You don't have to memorize the formula. I just want to explain how people derive these formulas, by hand. For those mathematicians who did the work in the past, that's how they do it. But our goal is to solve for a certain variable, right? In this case, let's say we want to solve for h. In this case, then first of all, you're gonna switch the terms, right? Switch left and right. Write 2 pi r times h plus 2 pi r squared equal to s. And then in order to get this term by itself, we need to get rid of 2 pi r squared. So that's why we subtract 2 pi r squared from both sides of the equation. Okay, so now we cancel this variable term, right? So we get 2 pi r times h. Then on the right hand side, s minus 2 pi r squared. And from there, we're just gonna get h by itself. So we're gonna divide whatever in front of the h is 2 pi r. So here divide by 2 pi r. Okay. Once you do that, then we cancel 2 pi r. H is by itself, right? That's what we want. X minus 2 pi r squared on the top over 2 pi r. And that's the best we can do, right? We're gonna leave it like that. Right? That's we cannot cancel 2 pi r right here because there's a subtraction on top. So this is a final answer for this problem. Any question about this? All right, now you guys try this, right? In this formula here, you're gonna solve for v. Get v by itself. H equal to 4v times t, right? Minus 10t squared. Okay, let's go with solution. So here we want to V by itself. Isolate this term, right? So adding t squared times both side of the equation. So we may have to deal with a lot of variables, right? But it's okay. You just stay on the target. Our target is the V, and that's what we want. Stay with that. Make sure we just move it, isolate that term by itself. Eventually, we just get V by itself. So cancel 10t squared, right? And then we get h plus 10t squared left. 4vt. If you want, you can reverse the order, right? So we get to 4vt equal to h plus 10t squared. From there, we're going to get rid of 4 and t. So we're going to divide 4t from both sides of the equation. Only keep the v. V is the only variable we want. We want to keep. So cancel the 4, cancel the t. Now v is by itself. V equal to h plus 10t squared over 4t. Any question about this? We need a fraction first. So we need to do h plus 10t squared over 4t. And that should be right. It's the correct answer. Now let's, so yeah, then this, we're going to solve for y, right? So this is a linear equation. Right here, we're just going to isolate the y. Let's see if we can solve this. All right, guys, we have a Professor Dawes. He's joining us to explain the, I think, final exam and then all the review material from the water sign. Yes, so I'm gonna let him take over. Okay,
Thank you, Professor Lee.
definitely.
How are you doing, class? Good morning.
Good morning.
As Professor Lee stated, I'm here to help you with the final examination information. Professor Lee, can you turn on the chat momentarily?
Chat, right? Yeah. Let me see. I better use that. Where do I find that chat icon? Maybe I should make
You might
it.
have to sign into your account. I think you turned it off.
Oh, I
So
see.
class, I'm going to provide you with a link. Professor Lee, I'm just going to email it to you right now.
Sure.
And I'm having a testing meeting at 12 p.m.
Okay.
So if you could allow your students to join, I'd really appreciate it.
Definitely. Yes, I will.
So once I email it to you, do you want it at the BMCC email or your Gmail?
Yeah, BMCC email, please.
Okay.
I'm gonna add this. Let's see if I can, enable that. Add the order. I'm not sure if that will work, but I'll let you know. I keep it posted.
It's okay.
Yeah.
So I'm going to email it to you right now, and your professor can share it with you. And if he allows you to join, I truly appreciate it. I'm going to show you everything that you need to know about your final examination. And I'm going to show you what materials that I prepared for you to make it easy for you to understand. Professor Lee, can you confirm that you received the email?
Yes, I'm checking that right now.
Okay.
I'm gonna check.
And may I temporarily share my screen?
Definitely. Yes, I'm gonna stop share.
Okay.
Yes,
Yeah. Could you turn it on for me?
Yes.
Thank you.
Definitely. Yeah, go ahead, Professor Dawes.
Okay, thank you very much. Can everyone see my screen?
Yeah.
Yes.
Yeah.
So this is the information that I emailed to Professor Lee. It's going to come with the link for the meeting at 12 p.m. and the meeting ID and the code. There's going to be a separate link at the end. That link at the end is to register for WebAssign. I will provide it during the meeting as well, but that's what you're going to need to register for the testing course. But you only need the first link to join the meeting. So Professor Lee, thank you for taking the time.
Yeah, definitely. Professor Dawes, I received your email. I'm gonna forward to the entire class. Yes,
Thank you so much.
yes.
I'll see you all shortly. Thank you for your time, class.
Okay. So all right, guys. So I'm gonna send it over Professor Dawes' email to all of you guys. So he's having the 12 p.m. right? So you should join his Zoom meeting at 12 p.m. So I guess we will end the class a little bit earlier today. I'll let you join his Zoom meeting. So by the way, I want every one of you guys receive the email. So I'm gonna send over via the CUNY first. So it's important because the final exam is like the exit criteria, right? You need to pass the final in order to pass the course. So I'm gonna send over right now in order for our students. So yeah. Okay, so I'm gonna send over. Sorry, emails. Zoom meeting about.
Oh, hold on. I'm sorry. I wasn't paying that much attention. What's the point of the next meeting that we're going to?
That's about final exam. So Professor Dawes is going to explain to you guys how the final exam works. And also because in the final exam, you're going to need to upload the PDF file of your work. And he will be there to show you how to do that. So that's very, very important, right? Okay, so sending that right now. I'm in the process of sending out an email. I can share the screen. So it's better you join his Zoom meeting. I'm sending over the Zoom meeting link. And he's a testing coordinator, so he can better, explain everything. So now that's a Zoom meeting link in this email right here. Right, you just click on that and take you there at 12 p.m. Right? Okay, so I'm standing over right now, sending notification. Check the email, right? Most of you guys still using the BMCC email, right? You see, most of you guys, I see most, and then just copy, personal emails. But let me know if you didn't receive it, right? I can actually post this information also in our Brightspace course. That probably will help too. So I'm gonna do that right now. I'm gonna post this, Brightspace course. Also, you need to, because he's going to show you how to enroll in the website, right? Your final exam will take place in the website. Okay, let me log into the Brightspace. It's kind of slow. So let me log into Brightspace. Yeah, I'm gonna create a announcement, right? The first announcement right here. You're gonna see why I'm doing this, and then you need to new announcement. Okay. About the final exam. Okay. So this is the one. Okay, and I'm gonna publish this, so you will have access to the Zoom meeting link. So yeah, so I guess I finished the class at 12, and you guys can join Professor Dawes' Zoom meeting, so he can better explain to you about the final exam process. And it's a high stake exam, right? You need to pass it in order to pass the course. So I strongly recommend you to join, so you get a better idea how the final exam works and what kind of requirements for the final exam. All right. Any questions before I end this section?
What homeworks do we have to do specifically? Because
Yes, so basically whatever we covered today, right? I'm gonna show you right now. Corinne, it will be, if you go there, homework set, you're gonna see I post up to we up to this 2.5, right? So I guess you guys can do 2.1 all the way to 2.5. I didn't talk about the other three yet. 2.6, I haven't talked about that yet. 2.8, I haven't went over that yet. So we're gonna get to that next week, next Monday. Okay.
Yeah, I got a question.
So yeah, okay, very good. So
when is
yes.
when is the final test?
Our final test will take place on August 15th, right? That will be the last day of the Immersion 3. And then on August 14th will be next Thursday, right? And then on next Wednesday, on August 14th, we will review for the final exam. Any other question? I see Enta, you have the hands up. Do you have any other question? No? Okay. In that case, I will stop the class now and so let you guys join Professor Dawes. Yes.
I didn't receive the email for the next Zoom call.
Zoom call. You mean for the final exam, right?
Yeah.
So do you have access to the Brightspace?
Yes.
Okay, so if you go to Brightspace, I just uploaded there. So if you go to Brightspace, the link is here. It's in our Brightspace course. If you go to course home, you're gonna see. You see, I post a message, post an announcement about the final exam what assigned, and this is the Zoom meeting link. If you want to join, you should join though. And I think you should join this. Sarah, you have questions? Yeah, sure.
Yeah, that's what I was gonna say. We can join now, right?
Yes, you can join now, guys. I'm gonna end the section, so we're gonna talk on Monday, right? Have a nice weekend, guys.
Have a nice day. Bye.
Okay,
Bye.
bye, guys. Nice weekend.